We're surrounded by these incredibly complex systems that just work. But behind the curtain, there are all these invisible rule books making sure everything doesn't go completely sideways. Today, we're going to crack open one of the most important ones.
Just think about it for a second. An oil refinery, an offshore platform, these places are basically swimming in flammable vapors. But at the same time, they're buzzing with electricity, motors, lights, you name it. So that presents a huge challenge. How on earth do you mix immense electrical power with super flammable fuel and not have it all go boom?
The thing is, you can't see the danger most of the time. Flammable vapor is invisible. So engineers needed a system, kind of like a safety map, to navigate this risk. They had to find a way to make the invisible visible. And that map, well, it has a name, API Recommended Practice 505. This is the guide, the rule book, that professionals use to classify these hazardous locations and, most importantly, keep them safe. Now, this document from the American Petroleum Institute isn't just a friendly suggestion. Oh no, it's a safety playbook, really, built from decades of tough, real-world experience. It gives everyone a common language so they're all on the same page when it comes to electrical safety in these super high-stakes places. The whole system really kicks off with this one key idea. We're not talking about a whole facility being dangerous. We're talking about specific spots, what the standard calls hazardous or classified locations, where flammable vapors and air could mix into, well, an explosive cocktail. But here's the thing. It's not just a simple, yes, it's dangerous, or no, it's safe kind of deal. The risk is more of a sliding scale. So once you've flagged a spot as potentially hazardous, the real work starts. You have to figure out just how likely the danger really is. And this, right here, is the heart of the API 505 system. It breaks down all that risk into 3 distinct categories they call zones. And the single most important factor that decides the zone is likelihood. It all boils down to one question. How likely is it that an explosive atmosphere will be there? Let's start at the top, with the most serious level, Zone 0. The key words you absolutely have to remember here are continuously or for long periods. This isn't a place where danger might happen. No, this is a place where a flammable atmosphere is just the normal state of things. It's ground zero for the hazard. To make this super clear, just picture the empty airspace inside a fuel tank. Could be your car. Could be a giant storage tank. That space is pretty much always filled with flammable vapor, right? That is a perfect example of a Zone 0 environment. The hazard is always there. Okay, so let's take one step back from the edge to Zone 1. Here, the hazard isn't there all the time, but it is likely to show up during normal day-to-day operations. We're talking about routine stuff, like maintenance or taking samples, things where a release of vapor isn't a surprise. In fact, it's kind of expected. Sticking with our gas tank analogy, Zone 1 is like the area right around the opening of the tank while you're pumping gas. You totally expect some vapors to escape during that normal activity. It's not continuous like the inside of the tank, but it's a predictable, regular thing. And finally, we get to Zone 2. Now, this is an area that's safe pretty much all the time. A flammable atmosphere is not likely to be hanging around. The only time it gets hazardous is if something goes wrong. An accident, an equipment failure, something out of the ordinary. And to finish our little analogy, Zone 2 is the larger area around the gas pump. Normally, the air there is totally fine. But if somebody has a spill and gasoline goes everywhere, well, that area could suddenly become very hazardous. The danger is purely accidental. And when you lay it all out like this in a table, the logic just clicks, doesn't it? You can see the progression perfectly. Zone 0, it's continuous. Zone 1, it's likely and normal. Zone 2, it's unlikely and accidental. It's just a simple, really elegant way to grade an invisible risk.
So that's the theory. But how does this actually get applied in the real world? Let's take a look at where engineers actually draw these zone maps in a huge, complex petroleum facility.
So, like we talked about, Zone 0 is for places where vapors are pretty much a permanent resident. In a real facility, that means the vapor space inside storage tanks or the space inside a vent pipe that's designed to carry those vapors away. Zones 1 and 2, on the other hand, are usually found around pieces of equipment that might leak. For example, the tiny area right around a pump seal that might let off little puffs of vapor during normal use, that might be Zone 1. But bigger, more open areas like a drill floor, which only get dangerous if something goes really wrong, are classic Zone 2. Okay, so we've identified the hazard, we've mapped it all out into these 3 zones. But so what?
Why does all of this careful classifying matter so much? Well, this is where the rubber really meets the road.
The standard itself gives us the answer, loud and clear. This whole mapping exercise, this whole system, has one ultimate goal: to guide how you choose and install electrical equipment. It's basically a safety instruction manual for the engineers.
And this is the absolute key takeaway. The zone map isn't just a warning sign about danger, it's a blueprint for safety. Each zone, 0, 1, or 2, tells you exactly what kind of electrical gear you have to use. And this is special stuff, designed and certified not to create a spark or get hot enough to ignite anything. A motor built for Zone 1 is a totally different beast than one you'd use in a safe area.
It really all comes down to this simple, life-saving logic. First, you map the risk, you identify the zone. Second, you pick out the electrical equipment that is certified for that exact zone, and the result? You've taken away the ignition source. You've broken the fire triangle. You've prevented a potential catastrophe.
You know, the API 505 zone system is just such a powerful example of how we manage these invisible risks all around us. It kind of makes you wonder, doesn't it? What other hidden codes and unseen standards are quietly working in the background, making our complex technological world not just possible but safe? Definitely something to think about.